I am a student of Netaji Subhash Engineering College. Today I will be making or designing a waveguide using HFSS. So let's start. We click here to get a design started. So we now have our model. Let's bring it to the center. We now make a rectangular box. Take any random box and name the box as let's take it as WG, and the material as taking the material as copper. We type here C, copper, and select OK. We make it transparent so that we can see it over other objects. And now our waveguide structure is created. Now we select this and select its XYZ size. We let the position as 0, 0, 0. We choose the X size as some variable A and do its value as, first let's change the unit to 0.9 inches. And select the Y size as some B. Select its size as 0.4 inches again. Select the Z size as some variable minus L so that we can set L as, we do it against the negative Z axis, so take L as 20 centimeter. Select OK. And now let's see. Our waveguide. And now we copy this waveguide, Ctrl C and Ctrl V. A new waveguide WG1 has been created. We name this as outer WG. Outer WG is also copper. And name this one as inner WG. Now let's change the outer WG as only WG and inner one as WG1, and we can change the outer WG as C minus T comma T comma minus T comma 0, where T value I'll assign as, let's take 1 millimeter, and change the X size as, since it is outer box, we can do it as A plus 2 times of T, 2 times of T, and we can copy this and add it here too, B plus 2 times of T, and Z remains same, minus L. So our outer and inner has been created. Now we subtract the two by selecting the outer, inner, outer, control, inner, and select subtract, outer minus inner, select OK, and our waveguide has been created, the subtracted portion. Now we define a rectangular port at one side. We select draw rectangle, and from here to here we randomly do it, and it comes along unassigned in rectangle 1. We name it as something like port 1, port 1, make it transparent, and now we do its position as 0, 0, 0, and x-axis as A and y-axis as B, and now we can see our port 1. The port 1 has been created. Now we create a similar port by clicking the port 1 and doing Ctrl C and Ctrl V. A port 2 has been created. Now we select the port 2 and change its position as 0, 0, minus L at the other end of the waveguide. Rest remains the same. We can see the port 2 has been created. Now we assign an excitation at port 1. So how to do that? We can right click on port 1, assign excitation, and select it as, we will select it as a lumped port with 84 ohm. So here it is given 50 ohm, we'll change it to 84 ohm and select next and use it a new line, and do this. Now we create a lumped port with 84 ohm and select the new line as starting from here towards the y-axis, Let's see what's the problem. Now we define a new line from here and select it from this end to this end, and now it shows defined. We select next and do not renormalize, and we finish. We can see our port 1 has been assigned. Now for our port 2, we do for port 1 as wave port, name it as 2. Select finish. Our port 1 name it as 1. So our port 1 is under wave port, and now our port 2 should be under lumped port, and this should be for 84 ohms, and a new line should be created. We first zoom it a little bit, and define our port 2 as lumped port with 84 ohms, and draw a new line here. Is now defined. We select do not renormalize. We finish. Our port 1 and port 2 has been created. As you can see, port 1 and port 2. The next thing we do is, so we can show from here, from HFSS into fields, you can do edit sources and show where port 1 and port 2 are acting like. Here the port 1 is acting like the source and port 2 is acting like the end point, so no need to change this. So we can add the solution setup now. We can do this by selecting on analysis, add solution setup, select the solution frequency as somewhat 10 gigahertz, because we know for WR90 waveguide it is between 8 to 12 gigahertz. So we select this, and maximum number of passes as 10. We don't select any of these and select OK. Now under analysis we can select setup 1. Under setup 1 we can add a frequency sweep. Solution frequency is 10 gigahertz. We select it as add frequency sweep. We can select it as fast sweep, and we can select the starting frequency as now we can do the select the start frequency sweep from 5 gigahertz and end it to 15 gigahertz. The step size of 0.01 gigahertz, that would be good. So we can select this as OK. So here the mode is mode 1. We can select, see this from here, mode number of modes equals to 1. So it is a dominant mode, working in dominant mode. So to create a radiation box, we copy this waveguide and paste it another named as WG2 and remove this subtracted portion and remove it from here also, and name this as rad box for the radiation box, and it is under the material vacuum. Shown here also, vacuum. It is transparent. Under vacuum you can select this, and the positions are same, -t, -t, 0. But let's change it to some other variable t1, -t1, -t1, 0, where t1 should be, earlier we took it 1 millimeter, t equals to 1 millimeter. Let's take it this time 4 millimeter, t1 equals to 4 millimeter. And now we changed this also as t1 and t1. The Z size remains same, -L. So select OK. A radiation box has been created. Now we need to assign this radiation box as a radiation boundary. Name it as rad1. It has been assigned as under radiation boundary. You can see. And now our design is complete. We can see it from here, all our tick marks. And under port field display we can see our mode 1 and mode 2. Now to get an electric field distribution, we need to draw a rectangle, suppose like this, taking arbitrary thing, and we get it under unassigned rectangle 1, and we first name it as suppose xy, make it transparent, and select the parameters as position as 0, 0, rose minus 40. It would be around z axis. X axis size should be a, which we defined earlier. Y axis size should be b, and we can see this has been created. This is used to get the electric field distribution. Now we can analyze this. After validating this, select analyze all. First we save it. And the analyzing takes place. It may take some time. So it's almost done, and we have created this WR90 waveguide, and this is only a designing window, and I won't be showing how to take out the results. It is very simple. Just right click on the plane and do a rectangular field plot, and we can see the different types of plots. So from here Right clicking on results, we can create model solution data report and rectangular plot. And our simulation has been completed. We can do different types of plots: polar plot, rectangular plot, Smith chart, which would not be discussed here. This is a designing of waveguide. Hello, I am Souvik Sen. This was my video. I am a student of Netaji Subhash Engineering College. Thank you.